All right, guys, this is called, and I'm giving you credit points for these notes. Simplifying rational expressions, part 2. We already did part 1. You had an assignment on part 1. If you have not turned that in, the notes or the assignment obviously needs to be done ASAP. But these notes are pretty much the same thing. I want to go over it again because it's super, super, super important. Especially all of y'all are seniors. A lot of you are probably going off to college next fall, and you're going to have to take a placement test, probably the PERT. And something like this, it's going to be really important for you to know how to do it so that you can get a nice score on that PERT. Also, the factoring that goes with it, very important. All right, so that's why we're doing another lesson over the same thing. And there's so many different rational expressions and different things that can happen that I want to do it again. Okay, so example 1, we're going to simplify 16x divided by 20x plus 20. Now, could I go ahead and cancel those x's out? Nope. Could I reduce a 16 and a 20? Exactly, good job. 16x is one term. A term is either a variable by itself, a number by itself, or the product of a number and variable or variables. Product means what? When you multiply, right? So 16x, that's 16 times x, that's one term. If I add or subtract anything else onto it, that becomes more than one term. One term can only be reduced with another single term, okay? And if you just have one term that's called a monomial, you can reduce part of it, all of it, it just depends. But if you have more than one term, so say the denominator is 20x plus 20, there's two terms there. I can only reduce that with another 20x plus 20 in the numerator since that's in the denominator, okay? But to simplify this, first thing we're gonna do is factor anything that we can, because after we factor, we might be able to reduce something, okay? If you have a monomial that's just one term, you don't factor a monomial, okay? You can, but it's not necessary. So my numerator cannot be factored. I'm just gonna rewrite it. Now my denominator, it's not a quadratic, right? Quadratic means your highest degree is a 2. This is a linear expression because the highest degree is 1. Remember, the degree comes from the exponent of the variable, and you look at the highest one. So this is linear. Only way we can factor linear expression is if it has a greatest common factor. Does 20x plus 20 have a greatest common factor? Yeah, what is it? 10 is a common factor, but is it the greatest? 20. Can I take any x's out? No. So I'm going to factor out a 20. And remember, to do so, or to figure out what's left, I'm going to divide each of the terms by whatever I factored out, in this case 20. So what is 20x divided by 20? 1x or just x? What's 20 divided by 20? 1. Is it positive or negative? Positive. What's inside parentheses is linear. Again, the only way to factor a linear expression is if it has a greatest common factor. It doesn't, so we can't factor any further. Okay, so again, can I cancel that x in the numerator with the x in the denominator? Not in this case, because this x goes with another number, right? Another term, there's two terms there. Now, the 20, that's just one term by itself. 16x is just one term. Those are monomials, okay? These are two separate factors. So could I reduce the 16x and the 20? Yeah, you can reduce, well, the x won't, no, but the 16 and the 20, Now, if I had x's in the denominator too, I could reduce with that x, but not because of the x plus 1. That goes together. But the 16 and the 20, I can reduce that. So what number divides into 16 and 20? What's the largest number? 4. Anything greater? No. So 4 divides into 16 how many times? 4 divides into 20 how many times? 5. So in the numerator, we are left with now 4 times x is 4x. In the denominator, reduce the 20 to a 5, open parentheses, x plus 1. Is there anything else that I can reduce or cancel? Nope, so that's my answer. Oh, excluded values. Yes, so what can x not equal? Because if it's this number, I'll get a 0 in the denominator. -1, that's my restriction or my excluded value. Because if x was -1, that would be -1 plus 1, which is 0, times 5 is 0, right? You can't have zeros in the denominator. Right on. Take earbuds out, please. Now, on the assignment from the number 1, when we did simplifying expressions, I think the first problem, there were no variables in the denominator. If there's no variables in the denominator, you don't have a restricted value. Okay, so you don't have to say anything about it. There's not one. Variables in the numerator, it doesn't matter. You can have a 0 in the numerator. That's okay. Right? Can you put that in your backpack? Your what? Oh. Oh, I thought you were on your phone. All right, any questions on that one? Okie dokie. All right, how about this? V squared minus 7v plus 12, quantity divided by 4 minus v. So in the numerator, I have 3 terms. In the denominator, I have 2 terms. Is there anything I could cancel out right now? No, because it's all or nothing. So let's see if we can factor either or. So let's look at my numerator. I'm going to do it over here on the side. V squared minus 7v plus 12. It is a quadratic trinomial. Quadratic because my highest degree is 2, right? The middle term has 1 degree. The last term has 0. You look at your highest degree. So this is called a quadratic. So we can factor that. We know how to do that, factor by grouping, right? Is there a GCF? No. Okay, what is A equal to? What is B equal to? And what is C equal to? So we're gonna make our little T-chart. And we need on the left side 2 numbers that multiply together to give us A times C. In this case, A times C is positive 12. And on the right side, we need 2 numbers that add to give us B, which is negative 7. All right, let's see. Negative 6 and negative 1. Will that multiply to give me positive 12? No. But it won't. It'll give you negative 7 when you add it, but it won't give you 12 when you multiply. What else could you multiply together to get 12? All right, let's see. Negative 4 times negative 3 does equal positive 12. And negative 4 plus negative 3 does equal negative 7. Boom. Now, again, a lot of y'all accidentally, in your parentheses, you'll put a 12 and a negative 7. That's not the numbers you pick. You use the numbers that multiplied on the left and added on the right. They're the same 2 numbers on both sides, so be careful about that. So when we're using the factor by grouping method, we are taking these numbers, and that's what we're going to rewrite the middle term with, right? So my first term we just bring down, kind of like in a quandary. The middle term I'm going to rewrite using the numbers from the T-chart, and I got to put a variable with it, in this case v. So it doesn't matter which term you put first. If we use different terms, our math will look different, but we'll get the answer in the end, the same answer in the end. So I'm just going to put minus 4v and minus 3v. Isn't minus 4v minus 3v, doesn't that give me negative 7v? Yes. And then the last term, that 12, I just bring it down. I don't know why I squeeze all this in the like tiniest space possible. So now that we have 4 terms, we're going to factor by grouping. This is not new. Y'all already know how to do this. Group your first 2 terms together. What's the GCF? V. Any coefficients besides 1? No, just V. So if I factor out of V, what's left inside the parentheses? What's V squared divided by V? It's V. What's negative 4V divided by V? Negative 4. No. Oh, I'm sorry, you're moving on to the next step. You're just faster than me. So remember, second group, your sign, you have to take out a sign. The sign is always the same sign as whatever the sign of the first term of the second group is, right? So in this case, that's a negative. And what's your GCF? 3, negative 3. Now remember, if the only common factor there is a 1, you got to take a 1 out. When you do this method, you have to have 2 terms in both sets of parentheses. If you don't take a 1 out, you're going to be missing a term. Okay, so if that's the only GCF you have, 1 or negative 1, you got to go with it. Normally, we don't take out the greatest common factor. But if you're doing this method, you got to. So I'm sorry this is squeezed in. Next one I'll use more room. So what's negative 3V divided by negative 3? V. What's 12 divided by negative 3? Negative 4. Is what's inside the parentheses identical? So we know this is factorable. If it's not identical, you either did something wrong. If you didn't do something wrong, then it's not factorable. Okay? So once we know it is, make 2 sets of parentheses. What am I putting in one set? B minus 3, right? That's what's on the outside of the parentheses. You group that together in one set. What goes in the other one? B minus 4. That's technically a GCF of these 2 terms. You're factoring it out. That's why you only use one of them. Can I factor either of these any further? No. How do you know, you say? Well, these are both linear expressions. Linear because the highest degree is 1, right? The only way to factor a linear expression is if they have a greatest common factor. If they don't, you can't factor it any further. It's not like a quadratic, okay? So my numerator factored to V minus 3 times V minus 4. Is it okay if I put V minus 4 and then V minus 3? Yeah. Yes. Now look at your denominator. Does 4 minus V, is that the same thing as V minus 4? No, because this V is negative, this V is positive, this 4 is positive, this 4 is negative. But also notice it's not written in standard form. That V should be first in standard form. And a lot of times, if your leading term's negative, they'll rewrite it like this. But let's take this over here on the side. See if I can do some rearranging. Now, would you agree that 4 minus V is the same thing as negative V plus 4? Is that the same thing? V is still negative, 4 is still positive, right? Would this cancel out with the V minus 4 in the numerator? Are they identical? No, V is positive, V is negative. 4 is negative, 4 is positive. It would not. But what if I factor out a negative 1? So it's negative V divided by negative 1. V, what's 4 divided by negative 1? Now would they cancel? Yeah. So don't forget that negative 1 is a factor. It does not go away. I don't really need to write negative 1. But if you just write V minus 4 in the denominator, you just change the meaning of the problem. It's negative is being distributed to the V minus 4. Now will anything cancel? The V minus 4s, right? Does that negative sign go away? No. So in the denominator, do I just leave a negative sign? Negative 1. Do you leave a negative in the denominator? No. I can move it up to the numerator. If I do that, I need to put parentheses around V minus 3 because the V is not the only negative thing. Or I could distribute it to the numerator and get negative v plus 3, right? If I distribute that negative, which you could see it as that, or they may write it as 3 minus v, because a lot of times they won't write the first term negative. So say this was a multiple choice, you could see that any of these three ways, this way, or this way, or this way. I don't care. They're all correct, but don't leave that negative in the denominator. Say the restriction. What can v not equal? Don't look down here when we got rid of the v's. Look up here when we could either look at the original or down here, but probably here is easier. 4 minus what would give me 0? 4. Because 4 minus 4 is 0, right? So v cannot equal positive 4. Otherwise, we would get a restriction in the denominator. All of these are correct. One's not more correct than the other. They all mean the same thing, so I don't care. I'm good with all of them. Cool beans? Anybody still copying? All right, example 3. Say again, what? You're welcome. Okay, how about 8p cubed plus 48p squared, quantity divided by p squared plus 14p plus 48. There is no equal sign. We're not solving, we are only simplifying. You solve equations, you simplify expressions. Expressions don't have equal signs. Is there anything I can just cancel out right now? No. Okay. So first thing we do, we factor where we can. Not everything's factorable. And then we reduce what we can. So let's look at our numerator. 8p cubed plus 48p squared. Is that a quadratic? No, because its highest degree is 3. There is a quadratic term, but you look at the highest and see what you call it, okay? This is called a cubic polynomial. Quadratics is when we do the t-chart and factor by grouping, right? So you can't do that only on quadratics. Okay, well, is there a greatest common factor? Just 8. 8p squared. Your common factor can be just a number, just a variable, or a number and a variable or variables, right? So we need to factor out an 8p squared. And that 8p squared does not disappear. Some of y'all make it disappear, like it never even existed. It doesn't have feelings or anything. It does have feelings. You can't just make it disappear. So to figure out what's left, I divide each of those terms by 8p squared. So 8p cubed divided by 8p squared. Well, first of all, what's 8 divided by 8? 1. And then p cubed divided by p squared. I had 3 p's, I took 2 out. How many's left? Just p, right? So 1p is the same thing as p. We cool with that? Sorry, I keep moving my paper around. All right, next term, is it going to be positive or negative? I got a positive divided by a positive. Positive. And let's just do this one step at a time. What's 48 divided by 8? Which one? 6, right? Y'all are making me. What's p squared divided by p squared? 1. So am I going to put 6 times 1? Just 6. A lot of y'all will just tell me it's a p. Well, if I had 2 p's and I took 2 p's out, there's no p's left for that term, right? Okay. Can I factor p plus 6 any further? It's linear. So if it's linear, the only thing that we could do to factor would be factor out a greatest common factor. If there's not one, it's factored, right? So my numerator is 8p squared times the quantity of p plus 6. Now, if I just leave it like that, would I be able to factor anything in the denominator? Or cancel, I mean? No. Well, let's see if we can factor that denominator. P squared plus 14p plus 48. It's a quadratic. My highest degree is 2. So if I can factor it, factor by grouping is going to work. What is A equal to? What's B equal to? What's C equal to? So my little T-chart, on the left side, you need two numbers that multiply together to give you whatever A times C is. In this case, that would be positive 48. And on the right side, you want two numbers that add together to give you B, which is 14. I hear 6 and 8. I hear 2 and 24. 8 and 6. How about 12 and 4? So we're going to go with 8 and 6. All right, 8 times 6 does equal 48. If it works on the left, should you just stop there and be like, well, there's my numbers? No, it has to work on both sides. So on the right side, 8 plus 6 is 14. So if you're not writing what I'm writing, you won't get full credit. And you need all phones to go in backpacks, please. Backpacks. So we rewrite the middle term. We're going to put an 8p and a 6p. They're both positive. Does it matter which one I put first? No, our math will look different if you do a different number than I do, but we should get the same thing. Now we have 4 terms. Group your first 2 terms together. Group your second 2 terms together. Factor out a GCF of each group separately. What is the greatest common factor of my first group? P. Factor it out. P squared divided by P is positive 8P divided by P is, very good. Second group, what's the sign? Thus, whatever this is, and what's your GCF? 6. What is going to be my first term? P plus 8. At this point, you know if it's factorable or not factorable. Is this factorable? Yes. If what's inside parentheses is identical, factorable. Make 2 sets of parentheses. What am I going to put in one group? What about the other? Boom. Can either of those be factored further? Okay. Now, real quick, what is I have 2 restrictions. What are they? -8, -6. Sometimes one of those will cancel out and students think you just look at your answer to find the restrictions. That's not true. Before you cancel, that's where your restrictions come from. All right, well, anything reduce, cancel, what? P plus 6 divided by P plus 6 is 1. We say it canceled. Now, if that was my whole problem, my answer would be 1, right? Not 0. And can I reduce or cancel anything else? Can I cancel this 8 and this 8? Reduce P squared and P? Nope. So my answer is 8P squared divided by P plus 8. I can put P plus 8 in parentheses if I want. There's nothing else in the denominator, so I don't have to. Right on, crouton. So let's do one more, and I'll give you your assignment, unless you feel like you need me to do more. All right, so we're good with one more? And then remember, a lot of you still owe me the assignment from Simplifying Rational Expressions Part 1. Let's go with n squared plus 10n plus 16 quantity divided by n squared plus 7n plus 10. Can I cancel out those n squares right now? What? Yeah. What? Are those just single terms not being added or subtracted to anything else? No, you cannot do that. N squared plus 10n plus 16, that's one polynomial. It all goes together. Same thing with denominator. So those aren't just monomials, right? So I can't cancel anything to begin with. So let me see if I can factor. I'm going to start with my numerator. Is there a GCF in my numerator? No, there's not. Remember, it's got to be a common factor of every term, not just two terms, every term. This is a quadratic, so if it's factorable, we can use the T-chart and factor by grouping. What is A equal to? 1. What is B equal to? What is C equal to? So in my little T-chart, I need two numbers that multiply together to give me A times C, which in this case is positive 16, and that add together to give me B, which is positive 10. And then 8 times 2, let's see. 8 times 2 does equal 16, but what is 8 plus 2? Does that work? Yes. So do I use the 16 and 10 or the 8 and the 2? 8 and the 2 is the numbers that we use for both sides. We're using the 16 and 10, we just look at how we label the chart, right? So that's what I replace the middle term with, and I give it an n as well. So bring down your n squared. Middle term, I'm going to do plus 8n plus 2n, or you could do plus 2n plus 8n. It would just be different. Plus 16. Thank you. Group my first two terms together. Group my second two terms together. What is your greatest common factor of the first group? N. We're going to factor it out. So what am I putting in the parentheses after I take out an n? N plus 8. Boom. Now we're getting so good at this. What's the GCF of the second group, including the sign? Plus 2. Is anybody confused about where I'm getting my GCFs from? Not 2n, right? Just plus 2 is what you said. So I will divide both of those by 2. What do you get? N plus 8. Is this factorable? Yes. What's inside parentheses is identical. Make two sets of parentheses. What do we put in one set? N plus 8. What goes in the other? Boom. The n plus 8 is only once because it's a common factor of this term and this term. We've factored it out. What is left is the n plus 2. So my numerator is n plus 8 times n plus 2. Do I get any restrictions or exclusions from the numerator? No, because your numerator can be 0. It's your denominator where your restrictions come from. So let's factor that denominator. It's also a quadratic. So if it's factorable, we'll be able to do T-chart and factor by grouping. Is there a greatest common factor? No. What is A equal to? What is B equal to? What is C equal to? Make my T-chart. We need two numbers that multiply together to give me A times C, which A times C is positive 10. And then add to give me B, which is positive 7. What do you got? 5 times 2 does equal 10, and 5 plus 2 does equal 7. So the 5 and 2 is how we're going to rewrite 7n. 5n plus 2n gives me 7n. If I use 10 and 7, if I forget, is 10n plus 7n 7n? 10n plus 7n is 7n? No. So I'll know, like, oh yeah, no, I'm replacing the middle term, so it should equal the middle term. So my first term you bring down, middle term, I'm going to use 5 and 2, make sure you put it in with it. It's 5 plus 2, 7, not 7n. I put it in. And then the 10, bring it down. Group your first two terms together and your second two terms together. What is the GCF of the first group? N. What is left when you factor out an N? N plus 5. What is the sign in GCF of the second group? Plus 2. What's left after you factor it out? Is this quadratic factorable? Yes. So 2 sets of parentheses. What do we put in one set? N plus 5, because that's the greatest common factor. We're factoring it out, and when we do, what's left? Look at y'all go. Now, do we have any common factors in the numerator and the denominator? Yeah. Say you had two of the same factors, but they were both in the numerator. They don't cancel out. To cancel, one's got to be in the numerator, one's got to be in the denominator, right? To cancel or reduce. So what are your restrictions? -5 and -2. If you're not sure, set your each factor equal to 0, solve for n. N plus 2's cancel. Can I just cancel out the n from n plus 8 and the n from n plus 5? No, binomial, all or nothing. So my actual answer is n plus 8 divided by n plus 5. My restrictions are -5 and -2. Are you always going to have a restriction? No. Only have a restriction when there is not just the denominator, a variable in the denominator. If you just have a straight up number in the denominator, well, you won't get a restriction for that because you can't plug in a different number for the number, right? It's only if there's a variable, because a variable could be any number. Coolio? Okay, so again, I'm going to come around, give you credit for these notes, and I'm going to assign you Simplifying Rational Expressions Part 2. Some of y'all still owe me Part 1, 2 different assignments. I want you to do this one first, and then if you still owe me the other one, do that second. That's what you're working on right now, nothing else. If you get both of those finished and turned in, then work on something else you owe me, or work on Imagine Math. You may not sleep. If you sleep, this assignment that I'm getting ready to give you is due today. If it's not done today, you'll get no maximum of 60%. If you're working diligently and you don't finish, then you can finish it for homework. Okay, but if you're sleeping or goofing off or doing something else, then it's due today, otherwise it's considered late. Right on? Okay. And I made a video of this lesson just like I did the last one. So I will be posting that in Schoology as well, in case you need a refresher.